Okay, so welcome everybody. Welcome to the last event of the season of this of 2024. And today we're going to talk about challenges and opportunities of distributed learning. So I'm Anne-Marie Kermarrec. I'm a professor at EPFL, actually working in distributed learning quite a lot on the system side. And we have the pleasure today to have two great speaker and active researchers in the field. So Peter Kairouz from Google, who is with us, and Giovanni Neglia, who is from Inria. So I guess I will give the floor to you guys, probably starting with Peter.
So hi, everyone. I'm Peter with Google. Um, I lead a small research team. We work on distributed systems and algorithms, federated learning analytics, differential privacy. And I want to tell a small story before we start this discussion. And the story has roots in the recent surge in large models and LLMs. Um, and the idea is that we've already trained on the entire web. If you look at some of the latest models, you'll notice that they're trained on something like 50 trillion tokens after cleaning up the data, deduplicating all the replicated information. And by all estimates, that is about how much we have data on the web. And so, what do we do now? We are starting to saturate on some of the metrics. The scaling laws are in questions. Where do we go from here? Are we stuck? Should we, be worried? What do we do? And my thesis in this talk is that even though, in terms of web data or public data, these are things like Wikipedia, news websites, blog posts, research papers, so on and so forth. Even though we've exhausted that distribution, for us to get real improvements and to march forward in this progress, we really have to tap on new sources of data. And that is data that belongs to entities like end users, smartphone users. It is patient data. It is institutional data. This is data that captures a lot of nuances that you would not find in open web data. For instance, let's say we want to create a really smart medical assistant, and we want that medical assistant to be personalized, knows how to diagnose very complex issues. How can we just by training it on open source books and Wikipedia articles and open source code get that very smart medical assistant? We need to tap on medical patient data, on biometric data, imaging, blood work, all that kind of things. But these types of data sources carry a lot of risks. First of all, they're not all centralized and in one place. So we need to learn how to train on largely distributed sources of data. They are not physically present in one location. Second, they carry a lot of privacy risks. We don't want these models to overfit or memorize anybody's sensitive information. We don't want the model to regurgitate that sensitive information. So these things happen all the time. And my colleagues at Google actually specialize in attacking models and trying to extract from these models training data. And what they have demonstrated across the board is that for whether it's language models like GPT-2 or ChatGPT as a system, you can extract training data. And not only can you extract training data, you can extract training data that is sensitive. This contains things like people's names, emails, addresses, fax numbers, phone numbers, so on and so forth. So we need to be a little bit aware of the propensity of these models to retain and regurgitate that information. But even in image models, we can also reproduce images of individuals that were present in the training set. So we need to do this with care. And I'm arguing that there's going to be a lot of training data sources that we need to try to tease apart and treat separately. So I'm showing you a hierarchy of training sources here. All the way at the top, there's public data. This is the data that we've trained these foundation models on, the GPTs and the Geminis and the Claudes of LLMs. And then there is semi-public data. These are data sets and data sources that we don't know exactly to what extent There's going to be licensing issues around them, whether or not we can just take them and use them. These are web scrapes, forum posts, so on and so forth. But then if you go down this chain, there's centralized user data. These are emails, photos, search histories. We're getting very personal. This is centralized data, but it is still very individualized data. And then you can go even one step further and you can talk about on-device user data. This is things like all the clicks and swipes and text entries you put on your phone, interactions between different apps, locations, sensory data, so on and so forth. So you can see that this is the kind of data that we do not want to even centralize. And my thesis is that we have to not just train foundation models on the two top sources in this data hierarchy. We need to also learn how to incorporate user feedback and user data and in-domain data into these foundation models. And this is something that we've started doing. If you look at ChatGPT or Gemini, you give a lot of feedback to the system, whether it's in the thumbs up, thumbs down. You tell the system, this is not factually correct, this is offensive, so on and so forth. This is feedback. And the prompt itself contains also sometimes your images, sometimes your emails, sometimes your calendar entries, or your medical conditions, and we try to interact with that chatbot. So these prompts that you're feeding into the system are logged, and potentially we train on them to improve the quality of the system for the overall users. So this is one way in which we are starting to branch out and include these new sources of data. The other one is often what we do is we take these models and we distill them down to make them experts on one specific domain. For instance, I don't want a generalist like GPT or Gemini. I want something that writes perfect emails for all sorts and all types of use cases of emails or docs or slide decks, so on and so forth. So these are still large models, but potentially much smaller, rather than being maybe in the hundreds of billions of parameters. These are in the tens of billions of parameters. They still potentially live in the cloud, served in the data center, but they are specialized on in-domain expert data. And lastly, we will have to learn how to contextualize and personalize these models. Ideally, each person would have a potentially strong and large model on their own device, on their own computer, on their own phone. We expect these models to be initially in the order of 1 to 5 billion parameters. As our technology and our phones grow, they will become larger, and we will have even more powerful models. But these models are now supposed to capture your own preferences. So they're supposed to touch very, very personal information and specialize on it and use it. All right, there's another way in which we could incorporate the in-domain data. Rather than training on it, as we saw in the previous slide, we can actually try to have a retrieval system that in real time, depending on the prompt that people have to these large models, it could go and do some form of distributed private information retrieval and fetch the relevant parts of the knowledge in a distributed data set and add it to that prompt and then run the inference. And because these models are exhibiting what we call zero-shot learning capabilities or few-shot learning capabilities, they are good in-context learners. So if you give them the information they need in the prompt, they can learn. You don't need to necessarily retrain their parameters. And that is also a new way in which we could run these systems, but it is challenging to do this in a distributed fashion. So this is something that I hope we can talk about. RAG, which is retrieval augmented generations, is very centralized these days, although the data in the retrieval part is very decentralized in many parts of the web. And so we need to have a distributed version of retrieval augmented systems. And because we've started using these systems as agents, for instance, there are Gemini agents now that can help you connect to things like Google Docs and your Google Calendar and Gmail. We are starting to give them tasks. We are starting to tell these models to conduct those tasks. And that's why we need to better capture privacy at inference, not just at training. And this should be done using what we call contextual integrity, which is describing privacy as an information flow, as an appropriate information flow. And you capture it via the context of the application, via some norms and some user data. And let me give you a simple example. If I am talking to my medical doctor and I have a smart LLM assistant that is doing that, I do want my doctor to have access to my medical exams and lab work and imaging. Otherwise, that doctor would not be able to diagnose me properly. But if I'm talking to a restaurant and I'm trying to book a reservation, I do not want that restaurant to suddenly have access to my medical records. So based on the context and based on the norms, I want that agent to behave very differently. And so this is a very interesting new field. It has a lot of different parts. It requires understanding the context in an unstructured manner, because this is not structured tabular data. This is text and images and so on and so forth. We want to be able to discover the norms, what a person feels comfortable about, and it has a lot of systems and security research. One thing we've recently done is we've tackled this problem of what if the third-party entity that the agent is talking to ends up being malicious, and it can interact with your agent. Say you are trying to book a table for 6 people at 6 p.m. and the restaurant asks your LLM agent for your social security number, which is something we never share if we want to book a table at a restaurant. We demonstrate that these LLM assistants today do not have the capability of recognizing that this is not something that they should share in this context. And we propose a solution that attempts at separating these concerns. We call it air gap because it creates some sort of a firewall between the user data and that third-party entity. So with that, I'll close. But I wanted to say that across the board, there's open questions that are very interesting, that are at the core of distributed learning and federated learning and inference. So I hope we can discuss them today. And thank you so much.
Thank you very much, Peter. And sorry for the sharing. There was a glitch and yeah. So maybe before going to the questions, we can have Giovanni's standpoint. And then we'll go into Q&A.
Yes, thanks, Peter. Can you see the slide?
Yes.
Thanks, Peter, for the nice talk. I will be a bit more like historical, let's say. Peter has spoke us about the, really the future. Let me first try to, like not know the audience, tell a bit about federated learning. So that is probably has been a technique that has been proposed by Google, indeed, like 8 years ago, roughly, to train a machine learning model on user data without having this data be collected in the cloud. And so the motivation were to reduce the cost of data transfer, but also to protect the privacy of the users. And some people after have also argued that perhaps it's a more efficient way to train model from the energy point of view, even if this is debatable, and we can go to it later. And so the way the model is trained is through a classic iterative procedure. You have the cloud that sends the model to all the agents. They update the model on the basis of their data. They send back. The central node aggregates and go on. And so we can see this is a relatively simple scenario, but actually has motivated the research, a lot of research during the last years, because like it may seem that is a bit what we are doing in a cluster when we train a model in distributed way. But there are difficulties related to the fact that the communications are slow, they may be unreliable, and moreover, the distribution of the data is different from client to client. So every client is some way potentially pulling the model in a different direction, and this makes even proving convergence more complex than it was in the classic cloud setting, let's say. So the result, okay, this may have changed, is that in this setting at the moment, we train relatively small models, like the classic example is Google Keyboard. And moreover, people have shown that if you look at the communication between the devices and the cloud, you can still infer a lot of important properties of the data. You can reconstruct image, you can perhaps infer some sensitive attribute if you have some additional knowledge about the user. So, and this is the cross-device learning setting that is the one, okay, Google was mostly interested too at the beginning for obvious reasons, but Apple, Facebook, and many other went on the same direction. But there are also other stakeholders that are interested in distributed training for different reasons. So one classic one are hospitals. So hospitals may want to train a model on the data to predict a disease or something like this, but often they don't have enough data locally, and they cannot easily share the data with their patients. So you have now a situation in which consortia of hospitals are making agreement to be able to train models in a distributed way, in a federated way. And beside the hospitals, there are also the case of companies that may have headquarters in different countries, and then because of legal issues, they cannot share the data of their customer. They cannot collect in a single place data of the customer, and so they go through federated learning to respect the law. Like now we can push the future forward, and probably these two worlds are going to converge. And you can imagine, for example, that if you are training a medical model, yes, you have some data of the patients that perhaps is in the hospitals, but you may have other data that is, for example, continuously collected by some wristband or some health device that the user brings on himself, herself. And so you start having more fuzzy boundaries between cross-device and cross-silo federated learning. And moreover, there are also the telecom operator that we know that want to play a role, want to sell edge computing services, taking advantage of all this infrastructure that they are deploying at the edge of the network. And for them, services like related to training or inference are particularly interesting. And okay, if you now consider this scenario, is obviously more heterogeneous than the one we have seen before. There are opportunities because now you have also more powerful node that intervene and can do some part of the operation. But things are not so simple because, for example, if you let more powerful node do more computation, for example, work more to update the model, the risk is that you introduce a bias, no? So the model can be more adapted to the data of the user who is working the most. And this is just an example of a variety of trade-off that you have in these settings between the quality of the model, the privacy, and the resource efficiency. And it's very difficult to improve one of these three metrics, one of these three aspects without damaging the other one. And this, I think that the space of the trade-off is still to a large extent not explored. I thought that in this context, okay, we have networking people probably listening to us. Perhaps some of them maybe even a PhD student or student who are projecting them toward the PhD. And so, I mean, one could think, okay, this is a topic classic for the machine learning community, why we should care, perhaps. And so the first thing I want to stress is that this is an important research topic in the networking community. I was actually surprised that in 2023 at Infocom was by far the topic for which there were more sessions. There were 6 sessions of federated learning, 2 on distributed learning, and still a few papers on federated learning here and there in other sessions. The second part why you may be interested is that there are network manufacturer, like for example Nokia, who thinks that federated learning can be a way to train machine learning model for network operation. So they have settings where you have a lot of data generated at the edge, and again, they don't want to move this data in the same location, or they fear that moving could reveal some confidential information, for example, about user mobility. So they would like to train models in a federated way. And the final point that may be of interest is that this is yet another application of the internet. No, internet was started being a way to move file around, then became a way to get real-time video and audio content. And now perhaps there is a new application of the internet where perhaps not in terms of volume, but in terms of importance, all the traffic that is related to training machine learning models or to serve inference may become very valuable. So it may be that you may be interested into developing protocols, a new way to manage the network that are more suited toward these applications. But a few, very fast, something that I think are very important topics. Well, one, I totally agree with Peter about the privacy issues. So it's not because the data is blocked in a given place that automatically we don't leak it when we train these models. Another aspect is that is important is that there is these are distributed systems, and as such is more vulnerable to attacks. And sometimes defending against the attacks goes against protect privacy, because, for example, you have some techniques that guarantees that even the central node cannot know who has been providing which update. Okay, so that's very nice. You can think you may hide in the crowd, but at the same time, also an attacker can hide in the crowd, and then we may become more difficult to put in place a defense system that will be able to identify a malicious client and kick out of the system. If we are in a setting where like we have users that have a very different amount of data, we need to find a way to convince the user with a lot of data and of high quality to participate to federated learning, because perhaps for them the final model will not be that interesting, no? So how do we build a data economy? How do we build economic incentives to participate? This is still an open activity. And then I want to conclude with a topic that is much more close to perhaps to the interest of this community. This is a topic I have been working for some time, but I think it's still open. That if you go back to this cross-silo setting, and you think about this node that talk in a kind of peer-to-peer way, you need to design the topology, who talks with whom. And this is actually a question that has many different aspects to look at, with different potential different metrics that leads to very different way to configure the topology. And this, I think, is still a topic where there's a lot to do. Okay, and that's the end of my short presentation.
Thank you very much, Giovanni. Okay, so I think we can now open the floor for discussion. Maybe before giving the word to our attendees, I'd like to ask a question that I'm very interested in, both your input. Basically, so this is about, it's been about 10 years now that, this seminal paper that Peter, you're the first author with on the federated learning came out. And I was just wondering whether this is something that is actually now, operational in companies, whether, what has been the impact and the main accomplishment basically in research. I know a little bit more. There's a lot of things going on, but in industry, it's a very valid question, I think, to understand what has been happening.
Yeah, thanks a lot for this question. I do want to correct one little thing. The original federated learning paper did not have my name, unfortunately. So I was not one of the co-authors of the original paper, but we wrote
the one after, at least, to challenges. Right. Yeah.
Exactly. To go back to your question, which I think is very important, I will speak mostly about Google's launches. I have a bit of an idea of some of what our other colleagues have done. At Google, we've launched so far, I think, more than 50 models that were trained with federated learning. The bulk of those launches, a little over 30 models, were in the context of the Google keyboard application. So think of these different models as next word prediction, sentence completion, spell checking, grammar correction, for a variety of languages. The Google keyboard app under the hood has many, many different languages, from Spanish to Portuguese to French to Arabic to English, so on and so forth. And because these are small models, they specialize each in a language. Of course, the whole industry is moving towards multilingual, something we can talk about. So maybe we're going to have one model that works really well for all these languages at one point. But today, that's what we've launched. And what makes these models very special is that, as Giovanni was saying in his presentation, they're not just trained with federated learning, which is already a very good step. They also are trained with differential privacy and other privacy protections. So they get formal privacy guarantees that are grounded in information theoretic and cryptographic primitives, which we believe is just as crucial as federated learning, if not more important, from the perspective of giving those formal guarantees. Other applications where we've deployed models are in Android messages, to form these messages, give suggestions. During the COVID era, the contact tracing models also relied on a form of federation as well. There are in the Android system and on Pixel devices, displaying the search settings. When you look something up and you want to find where to do something, there's a model that tries to surfaces up the application that you need to go to. Those are also models that are trained with federated learning. And one of the biggest ones also is the wake-up word for the Google Assistant. So if you have Google Home, those devices, those assistant devices, and you want to train them to understand speech, and especially the Hey Google wake-up word, those are also trained with federation. Outside of Google, I think both at Facebook and at Apple, there were several launches. I think Siri is being trained in a federated fashion. I don't want to speak about the details of what our colleagues are doing, but I think there's been very key successes. Giovanni also mentioned the cross-silo application. Mm-hmm. I know that IBM, NVIDIA, and many other players, even in Europe, in the healthcare sector, have deployed systems to do all sorts of analyses on medical data, patient data, to discover, breast cancer treatments and train models collectively. I don't know if Giovanni, you have any specific details to share.
Yes, I remember there is a paper who came out during the lockdown about analysis of COVID cases across hospital that was using cross-silo federated learning. And then in terms of the there are some commercial product. For example, there is a French-American company whose name is Hawkin, whose focus is really on federated learning solution for hospitals. And then we have a few contact with companies that are perhaps not really at the moment deploying this solution, but their kind of use case is a bit the following. These are companies that sell a service to different clients. So these clients are competitors, but may still be interested to learn something together. And so for them, federated learning will be a possible solution to train a model that benefits every company without giving too much information to their competitors. So it's obviously a tricky. And one of these companies I heard recently is L'Oreal. So they do product for the skin, and they're interested to collaborate with their competitors to do toxicology study about the ingredients that they are I mean the elements, the components of their products and so on.
Okay. Very interesting. So again, a question probably for both of you. So we are at the, I mean, for a few years now, especially since LLMs just, gain a lot of attention, basically models are getting bigger and bigger and bigger and bigger. So given this, does it still make sense actually to train small model on personal data in a federated fashion, really? That's a bit of a provocative question for all the researchers that we are in this area, but so what do you think?
Maybe I can start.
You can
So I
start,
think,
Inria.
yeah. So I think we're going to end up in a world where we have a variety of models. There will be models that are really, really big, and those models, I don't think that they will be necessarily trained with federated learning, although maybe across data centers there would be a role of a form of federated learning. But at the same time, these models will be called generalists, and we have seen versions of them, right? The GPTs, the Geminis, the Claudes, so on and so forth, or Mistral. Although in practice, what we want is something that specializes at two levels. One at the domain level. So for instance, health, and even there are subcategories of health, right? And then at the personal user level, we want something that is very personal to an individual user. And so because of this hierarchy of use cases, I think what's going to happen is we are going to quickly converge to a situation where we have all the way from potentially trillions of parameters of models, the very big ones that live in the cloud. Those we cannot obviously serve on device or anywhere near that. But we will have smaller models, maybe tens of billions, down to 1 billion parameters or even sub-billion parameters that are very personalized, contextualized, and specialized on certain domains. And they can talk to one another. Depending on the complexity of the user query, it's possible that if the on-device model cannot perform that task, we might need to go and access the larger models. And we're learning how to do this in a clever way. We don't want to run inference on a 500 billion parameter model when we could have gotten the same answer on 500 million or 10 million parameters, right? And so we're burning through a lot of compute a lot of times for no reason. So I think that this is one thing. The other thing is that technology is going to improve. I think that if we fast forward 5 years, the capacity of what we can train and store on device is going to improve maybe one or two folds. Technology is moving very rapidly, the silicon industry and whatnot. And also the algorithms are going to improve. I don't know if we necessarily need 500 billion parameters to get the capabilities that we have today in these models. It's very possible that we can get the same capabilities maybe at 1/10 of the capacity of these models. We don't know how much we can shrink these models, compress them, distill them, so on and so forth. This is a big open question. And so for all these reasons, I think federation is going to be critical for the future of AI. And a form of, multitask, multi-domain, hierarchical learning of these models is going to emerge. I don't know exactly how it's going to play out, but I can for certainty tell you that we need these algorithms and we need to evolve them to make them operate at larger scales. So yeah, that's my hypothesis.
Okay, interesting. Giovanni, and your take on this?
I essentially agree. We have actually a line of research starting in my team on what we call cooperative inference. And we really imagine a bit this evolution, let's say, from people that are in the network community, from content delivery network to inference delivery network, where you have an ecosystem of models that are spread in different points in the in the network that collaborate to provide the answer, as Peter said. So I mean, the model may evaluate if it's confident enough to address the question, or a smaller model, and then in case ask to a bigger model, or they can cooperate. And I want also to stress that this need to use a small model is also important from the environmental point of view, no? Because that we to do sometimes very simple things, we go on, we may invoke a ChatGPT model that takes a lot of resources to. It's quite scary, and this probably okay. There are some technological aspect. I'm also puzzled about the user attitude, because I know people that if they need to do a computation, they ask to on Google. So they don't even use the the calculator application on their machine. They just Google 7 plus 15 and they get 22. And if you think about what's happening under the hood for this to happen, so there is probably an education of people, but I'm not sure that because everything could be automatized. Know how to, but that's a much more difficult question that the research question we can address in our community.
Giovanni, you will be even more upset when you learn that people today are using GPT to do 7 plus 15.
Yeah,
They're using
no,
1 trillion parameters to do 7 plus 15.
Okay, and does
Yeah.
ChatGPT can answer that, yeah?
Sometimes.
So we have a question online. From Cyan Biswas, does forcing to have personalized model training for diverse communities present amongst the clients inevitably increase the risk of exposing sensitive information about minorities? Or how do you view this trade-off between privacy and personalization, or fairness kind of thing?
Yeah, I can start. I think that this is, first of all, an excellent question. There is this fundamental trade-off of you really want the model to capture the heterogeneity in a data set. And especially when there are minority groups, this could be demographics, it could be race, it could be gender, it could be a certain language, so on and so forth. You want to capture that. Otherwise, this model will not work well for everybody. But if we are training with things like differential privacy, these technologies are telling us that we should not overfit to statistics and preferences that belong to one individual user or a few users. So there's this intrinsic tension of, for privacy purposes, I don't want the model to learn this feature because this feature belongs to a few people. From a fairness perspective, fairness tells us, no, actually, this feature is important to the small community and the model should capture it. Otherwise, you're marginalizing this community. And so what do we do? One way out of this tension that a lot of people have proposed over the last few years is to combine, to do it in a two-step process. Step number one, you train a model that's, good for the overall population. Naturally, this model, if it has privacy protections, it may not pick up on things that are personal or things that belong to minority groups. But that's just step one. We're getting a good initial starting point. In step two, what you do is, if you can privately learn a clustering of your users, so in a way that does not reveal the private properties or the private attributes of the population of users, if you can somehow cluster geographically or based on the device type, device ID, so on and so forth, any property, whether it's race, gender, language, usage of the phone, then what you could do is you could take the model that you trained in phase one and you could do a mini federated training on every cluster, because you still have to go beyond one user, because a user will not have enough information to make the model much better. Maybe I have only 5 training examples. So we don't refer to this as necessarily personalization. You're not personalizing the model, but you're doing some sort of sub-clustered federated training. There are papers on this approach. Deploying it in production has proven to be challenging because what you need to do is you need this system that first runs the federated training across the entire population, and then you want an automatic private clustering that does not reveal to the server the sensitive attributes of each cluster, because that again goes against privacy. If I reveal that this is the cluster of non-religious people, or this is the cluster of whatever, X and Y, we don't want that. And then you want to run that training at that cluster level. So there are systems challenges towards achieving this. That's where the open question is. But from an algorithm's perspective on data sets, we've done good work. That's one approach to solving this problem.
Okay. Giovanni, do you have any insight on this?
No,
Not
I
particularly.
don't have anything
Okay.
to add to Peter.
So thank you very much, Peter. This is very interesting. Well, I have another question, but then we have a question online, so I'm just going to ask this one. So in your expert opinion, how important are incentive mechanisms in FL? Do you foresee incentives become a critical integrated component of FL systems in the future, especially as clients like autonomous vehicles begin contributing to the training of advanced applications? So Giovanni, maybe do you have?
Yes. No, as I said, I think yes, it's a critical element. I mean, how you make or there may be cases where like the user have a simpler decision, or they just are offered to opt in or in the system or not, no. And as it is the case for many apps, no, that today we install, and if we want to use the app, we give the right to use also some data that we have. But if you think now about companies that cooperate to train a model, different companies, then there is really a economic studies about is it worth it to share this data, no? And these the companies are used to do this kind of reasoning, no? Should we share supplier our supplier chain with a competitor or not? Good point, bad points, and so on. Now if we imagine something that is more distributed, there is all this research on the field of data economy, people designing marketplace for data where you can go, you can provide data sets and so on. I think a tricky part, a tricky aspect of data learning is that if you have this rule that you cannot share your data, no, that you don't show your data, then there is also an additional difficulty to understand if the data that you are offering is really valuable for who is going to use it. So now we would have the need to develop a kind of like auditing mechanism that can double check what is the quality of the data, double check what is the utility for the customer of the data in terms of the model. So, and I think there are a lot of research directions here.
Mm-hmm. Peter, do you have anything to add on the
Well,
incentive?
I think Giovanni summarized it very elegantly. I think this last bit that Giovanni talked about, which is that the quality of the data, how do you measure the quality of the data and compensate according to the wins and accuracy? That's, I think, a widely open question. It's a very interesting question. Even in the centralized, by the way, setting, this is not an easy question.
Absolutely.
For content creators. But when you go to the distributed setting, it adds layers. And I'm afraid of potentially people abusing the system. Like they would have very low quality, maybe even malicious data, and then they would make money by selling you junk. So like, how do we weed out attacks and malicious clients? The other thing that I think could be interesting here, I was actually once talking to a colleague of mine in Europe, and they brought up to my attention something that's very interesting, which is they told me that this could actually lead to exploiting people, meaning that if a person is already rich enough or comfortable, they would not be inclined to participate in such systems because the economic incentive is such that I don't want to make $10 or $100. My data is worth a lot more and I don't need those $10. Whereas in poorer countries where $10 or $100 could make a huge difference, that could push people to actually participate in these systems. And they value their data possibly less because of that economic barrier, right? And so it could create a disequilibrium in the system where people that perceive that are in more need of money could essentially go. So I don't know how to resolve this. Like this is fascinating. It wasn't even it didn't even cross my mind that I thought by rewarding people you're actually doing the right thing, but it turns out there's this complexity in the economy that could create issues. So these are the things that I'm not saying this is not solvable. I'm sure there are ways around it, rewarding in different mechanisms, so on and so forth, that could ensure participation of everybody. But these are the kinds of questions that we need to think about.
Very interesting. Actually, I have maybe that's a very naive question because you said that FL was sort of deployed, for a number of applications. But is there, what is the impact of, running an FL algorithm on a phone or something for the user? And does the user even notice it, even knows it? How does that work?
Yeah, I think I want to go back to what Giovanni said in his presentation, that especially for smaller models, it turns out that running FL is better for the user. We're not just talking privacy. From a sheer battery usage and from an environmental perspective, because if you have these very small models, tens to 50s of megabytes, then the amount of compute you need locally is so small. And communicating those models, especially if you use compression techniques, and that's again something that Giovanni presented and talked about, that can drive the costs, the environmental costs, compute costs, transfer, communication, down to a minimum. The issue starts kicking in when you go to larger models. There's a tipping point beyond which we cannot justify training models on device. Even if you have the amount of compute and memory needed, even if my device can, for instance, train a 500 million parameter models. We can do that today, by the way. But I don't have a lot of data. It's way more environmental friendly and better for the user to actually move the data to a trusted, secure place in the cloud, do the computation in the cloud, then to run that computation locally. There are some research papers. I saw one actually from Meta, from Facebook, that tries to analyze the environmental impact and the power consumption. And they have plots in that paper where they show that as the model size increases, there's a tipping point beyond which federated stops being useful from that perspective. It could still be something you want to adopt for privacy reasons, so on and so forth. But from the environmental perspective, it stops being useful. I don't know if Giovanni, because you brought it up, I wonder if you have some thoughts.
Yeah, no, now this recent Meta paper. Perhaps I will write you to have the details. I think perhaps also I totally agree with your answer. Perhaps to complete, usually the way it's done, the training is that it occurs when when the device is connected to the Wi-Fi, when has enough battery. So in this sense, there are mechanisms to try to make it less intrusive, less notable for the user. Obviously, you don't want that while you are going around, the battery of your mobile is consumed by some training. So I think there was also this aspect perhaps in the question of Anne-Marie. Yes.
Okay. Thank you very much. We have 8 minutes. There is nothing, no question there in the Q&A. I have one which is related to maybe what you talked about, Giovanni, about IoT kind of devices. So how do you see the challenges in that area of integrated IoT devices into FL? And
Yes.
and more generally, like, and that is for both of you guys, you know, when you have, you know, very different sort of capabilities of participants, basically.
Yes, yeah, I think there are two interesting aspects. So the first one is that if you imagine really all these heterogeneous devices that want to participate to train, at the moment, let's say the simplest solution will be that you adapt to the capabilities of the smallest device. But that's obviously bad, no? I mean, what is the interest of someone who could run, for example, a more powerful model um, you know, like accept to trying to run a very simple one. So at the moment we have some solution that have been proposed, like mechanism based on knowledge distillation or on sharing a subset of the parameters. But I think here there is still a space for research. I don't think we have find the final way to really be able to jointly train a different architecture suited to the characteristic of the device. And then something that is for me particular to IoT is that we may have a different setting from the classic one where there is a data set that is static, that is at the device and so on. No, because we may have continuous generation of new data on devices that have a limited amount of memory that they can devote to store this data. And so it seems that the device should learn what to keep in order to help the training process as the training process goes on. And there are interesting theoretical questions because now in these data streams, you may assume that the data may be very much correlated over time, but also over space across device. So now how you do training in these settings is well, we have some results, but we are far from knowing everything.
And maybe you even want to forget about some of these data at some point if they're no longer relevant.
Yeah, I mean, there are all these problems. It may be that some of these issues are related to what is called continual learning, no, where you may have a distribution shift and you want to track it, but at the same time, you should avoid to forget stuff that you have learned before. So these are, yes, definitely. I mean, the literature on continual learning is relevant for this kind of problems.
Mm-hmm. So, Peter, anything to add on this topic?
No, I think Giovanni summarized it very, very elegantly.
All right, so I think we're getting close to the end of this seminar. So, is there, just a word of wisdom that, or you guys would like to finish with? No, last.
I can say
comment on the
something.
topic?
I can say something that I think is interesting. There is in our community today a big bet that a lot of people are making on synthetic data. And I think that the way that synthetic data is being proposed today is that, hey, we've trained these large models, and what we're going to do is, in order to solve this problem of we don't have data to train on anymore, what we're going to do is we're going to take the models that we've trained, we're going to poke them sufficiently many times, create new data, and here you go. You have more data, train on it. And it makes me laugh because my background is information theory. I think Giovanni is smiling because I think he also has a very principled background. So where's the information coming from? Are we creating information out of nowhere? Impossible. Now, obviously, this can help. I'm not saying that this won't help because you're just re-emphasizing certain data points, and maybe these models, because they're instruction tuned, they help you to go to certain avenues and upsample across certain modalities or domains, and then you you get better representation of data, you're reinforcing certain patterns that the models have already learned. But that is not going to fundamentally change the equation or allow us to scale orders of magnitude. That being said, I do believe that synthetic data, if done properly, can help. And here's what I mean. What I mean is that, and this maybe also goes back to a point we were discussing before, which is, we're not going to train 500 billion parameter models on device, but what we could do is we could try to go to these avenues where there's new rich data, and we could train a much smaller generative model to get a synthetic copy of that distributed data set. So rather than have that data set spread out on 500 million users or 1 billion users, you want to put it in one place to train on it. So use the power of federated learning techniques with generative modeling and differential privacy and all these privacy technologies. But don't train a very large model, a small model, because this is anyway small number of training examples per user. It's not the scale of the web in terms of tens of trillions of tokens. But then you could create a synthetic copy of the distributed data set that's audited, that's vetted, that's differentially private, that's safe, so on and so forth. And maybe if you then take that synthetic copy that's differentially private and you add it to the training set of these large models, maybe then we can improve the performance of these generalist models. So because we've exhausted the web and the public, maybe now what we should look into is tap on new sources, but these are naturally distributed, very decentralized, very sensitive sources of data. So we could maybe leverage this idea of synthetic data, but not by using already trained models, but by tapping on new sources of data. And it's not easy. I think it is interesting, how to do it in the most efficient way possible, at the lowest cost possible, in the most private way possible. These are interesting open questions. And will it actually improve these generalist models? If let's say hypothetically, I take all Gmail emails and I create a synthetic copy that's differentially private, that's audited, that's vetted, that's cleaned up, no personal email users or proprietary. Will it ever improve Gemini? I don't know. It's unclear. Does Gemini even need that data? Or does GPT need such data? Those are the kinds of questions that are interesting to answer, I think, in this avenue. And federation, again, plays a role in accomplishing this mission.
Okay, thank you very much, Peter. Giovanni, your last word?
No, I think it's okay. We can close with these interesting ideas from Peter.
Yes. So before leaving, so let me first thank very much Giovanni and Peter for their insights and enthusiasm about the topic. I'm very happy to be here today and hear about all the interesting things that you guys have to tell us. So thank you so much. And also, I just would like to announce the next event of the networking channel that's gonna happen on the 22nd of January next year, and which is a fireside chat with Vince Cerf and Bob Metcalfe, organized by Christophe Dio from Google. So again, thanks a lot, Giovanni, Peter. Thanks a lot to everyone online and for your questions. And I wish you all the best for the end of year celebration, and a little bit in advance, very happy and successful 2025. Thank you very much.
Thanks,
Bye, everyone.
Anne-Marie. Thanks.
Bye-bye.
Ciao.
Thanks.
Ciao, Peter.
Thanks, everyone. Bye-bye. Ciao.